Okay, so this is a video for Pythagorean Theorem. If you are trying to, if you know two sides and you're trying to find the third side of a right triangle, then this is when you would use this first topic. So it's used to find the missing sides of a right triangle. And the sides A and B, which are labeled here, are the legs of the triangle. And then side C, which is across from the 90 always, is the hypotenuse. And for any right triangle, a squared plus b squared is equal to c squared. So the two legs squared and added together equal the length of c squared. If the triangle is not right, the converse theorem says that if a squared plus b squared is greater than c squared, it's going to be an acute triangle. If it's equal, we already know it's right. And then if it's less than, if a squared plus b squared is less than c squared, then it's obtuse. Okay, and so the way that you can remember this is that the symbol for the triangle qualification is opposite of what the acute symbol is for 90 degrees. So acute is usually less than 90 degrees. In this case, it's going to be a greater than symbol for the Pythagorean theorem converse. So if we do a couple examples of each of these, Pythagorean theorem. So first you want to be able to identify which side is C on each of these. So again, locating your right angle, it's going to be the angle, the side across from that angle. So in this case, this side would be C. In problem 2, X would be C. So go ahead and locate for 3 through 5 what other sides would be C. And then pause it. And then come back. So it should be 9, 30.5, and then 24. Okay, so once you have C, that's what's going to go on the side by itself. The other two sides, doesn't matter the order that you put them in. You can put 8 or 13 as A or B, it doesn't matter. So it's going to be 8 squared plus 13 squared equals C squared. And you solve this by squaring because you do order operations. So squaring exponents comes before addition in PEMDAS. So 8 squared is going to give us 64 here. Plus 13 squared is going to give us 169 equals C squared. Next step is to add the two integers together. So 233 equals C squared. And the last step to get rid of a square is to take the square root. The square's root. So the square root of something that's squared is the number again. So basically if I took the square root of 233, it's going to be 15 point, rounding each of these to the nearest tenth, it's 15.3, because I would look at the 6, since this is greater, 5 or greater, then I round this up to a 3. So 15.3 would be the length of the hypotenuse for this triangle. Okay, if I just do a couple random ones, so number 3, again, this was C, 9, so that's going to go on a side by itself. So I have 7 squared plus x squared equals 9 squared. And then I still square everything, so 49 and x squared equals 81. Now to get x squared by itself, I need to get rid of this 49. It's on the same side with x. It's currently added, and it should be positive here, so we would subtract 49 from both sides. So x squared is equal to 32 when you do the math out. And taking the square root of that, you get 5 point, again this is a 5 or higher, so this rounds to a 7. On the test in the DOC, if you do round it wrong, they count the whole thing wrong. So it is important that you can round correctly. If you're looking for the nearest tenth, you look at the hundredths place, 5 or higher, would round this up to the next whole number. Okay, so 2 and 4 are similar to those two problems. 5 is a little bit different, so we want to go through, if you're given a isosceles triangle that doesn't have a right angle in the corners, then they've got this diagonal line here, cut it for us to make a right triangle. So we want, in order to be able to use Pythagorean theorem, we have to have a right triangle. because we're setting a squared plus b squared equal to c squared. So if we were to look at just this side of the triangle, we have 24x, and then because these are equal, when I cut it down the middle, it's going to make equal sections here. So this is 11. And now I can use this for my Pythagorean theorem. Across from the 90 is c, so 24 would be c. So x squared plus 11 squared equals 24 squared. And you solve it like you did the algebra for the previous problem. Okay, so x squared equals, when you subtract 24 squared minus 11 squared, it's 455. And square root both sides, so that's going to give us 21.3. Okay, on 6 and 7, well, on 6, you don't have a right triangle already identified in the figure, but in order to do the Pythagorean theorem, again, you need a right triangle. So we can make our own cut. So in this problem, they made a cut for us, the diagonal line. We can make our own cut here. Okay, so 7 I'm going to help you set up, but then I'll let you solve this. So in order to do the Pythagorean theorem again, we don't know that this is a right angle because it doesn't have the right angle box. We know we have a right angle here and here. So what we want to do is cut x into two segments. We want to use A, I'll call this segment, I'm just going to give it any variable, it doesn't really, A is arbitrary. And then B, also any variable. So I'm going to have to do the Pythagorean theorem for the triangle on the right here, and I have to do the Pythagorean theorem again for the triangle on the left. In both cases, you want to identify which side C is. So in this first triangle, if I look at the right triangle, the triangle on the right, this side is C. So my setup would be 12 squared plus x squared equals 29 squared. And I have to solve that. That's going to get me just B. So that's just a piece of x, is not the full x. And then on this triangle, I would look at across from the 90 being C, so 14 would be my C. So 12 squared plus x squared equals 14 squared would be my other equation that I use. And then when I get those two answers, I need to add them together for my final answer. Okay, so that's the Pythagorean theorem. The converse, before we get into the converse, the first thing that you want to determine is if those three sides they give you can actually even make a triangle. So this is from the previous unit, where the small and the medium side have to add together to be larger than the large side. If the small and the medium side don't make us, the sum of them is not greater than the large side, then the triangle won't close and it won't form a triangle. So let's say you had a 1 centimeter side and a 2 centimeter side. If the last side is 10 centimeters, no way that you make 1 and 2 connect will ever reach 10 centimeters, so it won't be big enough to close and make a triangle. So in order for it to be a triangle, it has to, you just add the two numbers that are smaller and make sure it's greater than the last number. In this case, it is. So it checks out that it's a triangle. And then if you want to classify it by acute, right, or obtuse, you're going to use the Pythagorean theorem converse, so these rules up here. So you actually do need to square it for the second part of these problems. You need to square it and compare it to c squared. So if we do 3 squared and 7 squared and we compare it to c squared, we get 9 and 49 and 81. So 58 is less than 81, which means if I come up here, a squared plus b squared is less than c squared, so it's going to be obtuse. Okay. So that's what you're doing for these. You're doing two checks. The first check is to check to make sure it can make a triangle, and the small plus the medium has to be greater than the large. And then the second check is to see if it does make a triangle, then which of these three types of triangles would it make based off the sum of the squares of the A and B sides, smaller sides, versus the C side. Okay, when you're doing some of these other ones, you're going to have to use those same processes, but you're going to have maybe to do it twice or to figure out different things inside of rectangles and triangles to be able to get two sides so you can find the third side. So we want x on this triangle. In order to do the Pythagorean theorem, we need two sides known, and we don't know this side yet. But on this bottom triangle, we know two sides. So I'm going to use this dotted triangle and start here. I already know these two sides, so I can find side like y, for instance, if I give it the name y. Once I find y, then I can use that side in 28 to find x. So you're going to do the Pythagorean theorem twice. First time to find this side, which is a part of the second triangle, and we needed two sides of the second triangle to find x. So on this triangle across from the 90 is the 25, so 10 and y are your a and b, and you would solve for y. Then on the second triangle across from 90, the 28 is your x. So x squared plus whatever you got for here, for y, is going to equal 28 squared. Okay, and then you're solving that. So I'll let you figure out a couple of these other ones. For the applications, just a couple hints, because really this is it's seeing if you can read and if you can comprehend what you're reading. So this is going to really kind of mesh with English very well. So a roofer leaned, and you want to be able to visualize some things that are happening here. So a roofer leaned a 16-foot ladder against a house. So when you lean a ladder against a house, it leans. So it's going to actually have a slant to it. So you can make your house on the left or the right, it doesn't matter, but you do need to have some sort of house where there's a ladder leaning up against it. Okay, so if you were trying to climb up the house, you would take a ladder and then you would lean it against the house so you can climb to this part. So it's 16 feet is how long the ladder is. If the base of the ladder, so anytime you see base, it means like the bottom of the object. So the base of the ladder is 5 feet from the house. So we're talking about the base of the ladder to the house. And it's 5 feet from the house, so it's going to be 5 on the bottom. And they want to know how high up. That's going to be our vertical distance. So vertical distance being what we're looking for in this case. So we're still doing the Pythagorean theorem. I'll let you set it up, but that is the triangle that we're using to solve. So a lot of these you're going to have to find the triangle's two sides that they're giving you and then look for the last side using the Pythagorean theorem. So yeah, that's the Pythagorean theorem.